All right, in this video we're going to be going over how to factor polynomials, and this is hopefully a review as you should have taken pre-calculus and Algebra 2 and Algebra 1 before this course. But it is important that we review these things because for the calculus problems that we're going to do later, we're going to keep using these tricks over and over again, difference of squares, difference of cubes, factoring quadratics, that type of thing. So it's important that maybe we dedicate at least one of our videos to going over this skill. So there's not much to say on the first three, the difference of squares, difference of cubes, and sum of cubes. It's just recognizing this identity for each of them. Maybe more interestingly is like, how do we factor quadratics? And quadratics are functions of the form ax squared plus bx plus c. It's really easy when a equals 1, that leading coefficient. And we can just factor them as x plus alpha times x plus beta, where alpha and beta are the solutions to the alpha plus beta is this b term, where b is the coefficient in front of the x, and alpha times beta is this c, the constant. How do we factor quadratics with a not equal to 1? This is a slightly rarer instance. We don't see this one as much, but it does come up occasionally, so maybe it's important that we go over it. Probably the easiest way to do this is if you're not able to factor out the leading coefficient, if that leading coefficient isn't a factor of each of the terms, then we probably need to do something a bit more involved, which is using factoring by grouping. So I think the easiest way to do this is, again, we find two numbers alpha and beta such that alpha times beta is a times c, and alpha plus beta is b, where b is the coefficient in front of the x. Then we regroup the terms as we write this as ax squared plus bx plus c is equal to ax squared plus alpha x plus beta x plus c, and group the terms if we see common factors anywhere, factor out the GCFs, and then recognize the common factor. This will probably be easier to see with an example, and I think example 5 goes through this. All right, let's practice what we just learned. Let's factor each of the following completely. So for this first one, we could use this technique, the factoring quadratics by grouping with a not equal to 1. But actually, I don't think we need to do something that involved because notice that each of these terms is a multiple of 2. So we can actually rewrite this as 2 times y squared minus 8y plus 32. And then we just need to focus now on this thing, y squared minus 8y plus 32. Well, this is just the very first instance of, factoring quadratics with a not equal to 1. So we need to find two numbers, alpha and beta, that add to negative 8 and multiply, plus 16, not plus 32, and multiply to 16. It's plus 16 because this 2 times 16 is 32. Oh, and the answer to that is negative 4 and negative 4. So this is the same thing as 2 x plus negative 4 times x plus negative 4, which is just 2 times x minus 4 squared. Okay. What about this one, y cubed plus 8? Well, this is going to be a sum of cubes, right? Because this is the same thing as y cubed plus 2 cubed, right? Because 2 cubed is 8. So using the identity for sum of cubes, remember sum of cubes says a cubed plus b cubed is a plus b times a squared minus ab plus b squared. So in this case, a is y and b is 2. So this is y plus 2 times y squared minus 2y plus b squared is 4. All right. How about this example? This is a little unusual because, okay, I know there's maybe sum of cubes, difference of cubes, but 49 is a square, so this is a little odd. But notice actually that we can factor out an a from each of these terms. So maybe that should be our first step, is to rewrite this as a times 4a squared minus 49. Oh, and that actually does help us because now this isn't anything dealing with cubes. This is a difference of squares because this is the same thing as 2a squared minus 7 squared, right? 4a squared is the same thing as 2a, all of that squared. Okay, but by difference of squares, this is the same thing as 2a minus 7 times 2a plus 7. Okay, let's maybe look at one more example, or two more examples. This is going to be, I do recognize this. This looks to be two things squared because this is 4 squared minus w squared squared. This is using the fact that w to the 4 is the same thing as w squared squared. Right? W to the 4 is the same thing as w squared squared, using just like exponent properties. Okay, but by difference of squares, this is just 4 minus w squared times 4 plus w squared. Okay. And we have one more. For this one, we're going to need to use the factoring by grouping technique that we learned. That was like the last example. Okay, so we need to find alpha and beta such that alpha times beta is a times c, where a is the leading coefficient in front of the x squared and negative 4 is the constant. So find alpha and beta such that alpha times beta is negative 24 and alpha plus beta adds to the b term. So alpha plus beta is negative 5. And I think that negative 8 and 3 should do the trick. What multiplies to negative 24 and adds to negative 5, I think that negative 8 and 3 can be our alpha and beta. Yeah, negative 8 plus 3 is negative 5, and negative 8 times 3 is certainly negative 24. So using that now, we can rewrite this as 6x squared minus 5x minus 4. This is the same thing as 6x squared minus 8x plus, or let me write it as this, you'll see why, plus 3x minus 8x minus 4. Right, we use the fact that negative 5 adds to 3 minus 8, so let's rewrite negative 5x as the same thing as 3x minus 8x. Okay, and then this is the next part of our technique, is to group. The reason I wrote it like this is 3x minus 8x as opposed to the other one is I noticed that 6 and 3 have a common factor of 3, which I'm going to take advantage of. And then negative 8x minus 4, they have a common factor of 2, or of 4 actually. So let's group this as 6x squared plus 3x, and then this is plus negative 8x minus 4. Right, from this line to this line, like nothing happened. I just put parentheses around things that looked like they're going to have common factors. Literally nothing happened. This is just like convenient grouping. Okay. Oh, but now, okay, in this first term, or this first group, notice that 3x is a factor of both of those, right? 3x certainly divides 3x, and 3x certainly is a factor of 6x squared. So this is the same thing as 3x times 2x plus 1. And then from this, the second group, I can factor out a negative 4. This is minus 4, and then once again 2x plus 1. And you know that you've done it right. This is the factoring by grouping when there's a 2x plus 1 in both of these groups. Why is that convenient? Because now, you know, I can factor out a 2x plus 1 from each of these groups. 2x plus 1 is a factor of both of these. So this is the same thing as 2x plus 1 times 3x minus 4. So this is a complete factoring.